In this video, we're going to talk about two definite integrals that are a little harder than average. So the first one will be from -1 to 0. The integrand will be e to the x cotangent of e to the x cosecant of e to the x dx. So notice that if you try to use the substitution for cosecant e to the x, you will not be successful because there's no known integral for this yet. If you try to use the cotangent e to the x as the u, you will still be unsuccessful, right? Because cotangent of x times cosecant of x, for example, that can be integrated. But what are you going to do with the ex, right? There. So you have to, the only way that you can do this is to rewrite this. So write the e to the x and then write the cotangent in terms of sine and cosine, right? So it's going to be cosine of e to the x divided by sine e to the x, and then write the cosecant. So it's going to be 1 over sine e to the x dx. Okay, so now let's see what we're going to get. So we're going to get from -1 to 0 e to the x multiplied by the cosine of e to the x divided by sine e to the x squared dx. Okay, and now notice that it's going to be much easier, right? Because if you choose the u as the sine e to the x, then the du following the chain rule is going to be e to the x multiplied by the cosine of e to the x, and that's exactly what you have on the top, right? And now we have to change the limits of integration. So u as a function of x, when x is equal to -1, we get sine of e to the -1, right? Sine of e to the -1. When x is equal to 0, u as a function of x will get sine of 1. Sine of 1. So I'm going to use my calculator really quick. And I'm going to be in the radian mode just to check which limit is greater than the other so that we know what to do. So sine of 1 is 0.84. So I'm just going to put it here. 0.84, right? And this is equal to, let's see, 1 divided by so let's see, 1 divided by right, and sine of this will be 0.35. 0.35. Yeah, so we're consistent. We're showing consistency with regards to the upper limit being still greater than the lower limit. You see, that's why I checked this, because I wasn't sure just by looking at it. Okay, so let's see. So now, so we can rewrite this. So so the lower limit will be sine of e to the -1. The upper limit is going to be sine of 1. So we will have 1 over u squared, which is u to the -2. And this should be dx here. So ex cosine ex dx is already there for you, so it's just du, right? So now we're going to have -1 over u, right? The antiderivative integrated from sine e to the -1 to sine of 1. So that's going to give you -1 over sine of 1 minus, well, in this case it's going to be plus because there's already minus, so two minuses will give you a plus. Plus 1 over sine of e to the negative 1. Okay, so that's going to be your result. But let's use the calculator to check what it's going to be. Let's see, 1 divided by 1 divided by that's negative 1.18 plus 1 divided by in any case, it's going to give you a positive value. All right. Now the next integral that we're going to be looking at is going to be from 3 to 4, and the integral will be x times square root x minus 3 dx. If you use the u substitution as x minus 3, the du will be just dx. You might say, but what am I going to do with the x? Well, you can write the x in terms of the u, right? So x is equal to u plus 3, right? Rewriting the first equation. Now change the limits of integration with respect to u. So when x is equal to 3, u is going to be 3 minus 3, which is 0. When x is equal to 4, u is going to be 4 minus 3, which is 1, right? So it's going to be from 0 to 1, u plus 3 times u to the 1/2 du. Now it's going to be u to the 3 over 2 plus 3 u to the 1/2 du. So that's going to be 2/5 u to the 5 over 2 from 0 to 1 plus 3 multiplied by, so 3 over 2 the power, dividing by 3 over 2 gives us 2 over 3 as the coefficient, u to the 3 over 2 from 0 to 1. So that gives us, it's easy to integrate the 1 because it's not affected by the power, and we can ignore the 0, so it's going to be just 2/5 plus 2, right? Because the 3's are canceling out and 1 is not affected and 0 can be ignored. So now that's going to be, this is 10 over 5, so 12 over 5. That's your final answer. So I hope that you enjoyed this tutorial. Please subscribe to my channel and I'll see you in my next video.